everybody. Let's do IXL 6th grade R14. Go to Learning. Make sure you're on Math. Go down to 6th grade. And then down to R14. Identify proportional relationships from graphs. So this exercise is actually a pretty simple one. But before we do it, let's go over to Frydman Math and look at proportional relationships, which is on page 9. So we will scroll down to page 9. Here it is. And the first thing that I want to read is just the definition of proportionality. So we say that two quantities are in a proportional relationship if the ratio between them is always the same. And I'm going to talk a little bit more about that in a couple minutes. Now, for this exercise, we're going to want to know how to check if a relationship is proportional, meaning how to check to make sure that it satisfies this definition here. And for a graph, the way that you do that is you just make sure that the line is straight and that it goes through the origin 0, 0, which is this corner point right over here. So that's it. The line must be straight and must go through the origin 0, 0. Okay, so with that in mind, let's go back to IXL over here. And it says select the graphs that show a proportional relationship between x and y. So remember, how do we check that it's proportional? All we need to see is that it is a straight line which goes through the origin 0, 0. And this one satisfies those two conditions. So this one is proportional. And this one is also a straight line which goes through the origin 0, 0. So this one is also proportional. So we were able to check that these two graphs represent proportional relationships pretty easily. But let's also, just to see that this strategy works, that this way of checking for proportionality works, let's go back to the definition of proportionality, which is that the ratio between the two quantities should always be the same. So, for example, I can look at this graph over here and pick, let's see here, I could pick, oh, okay, so it's not really, there are no real good points to pick here. Oh, here's one. Let's see. Is there another point that goes? It doesn't really. Okay, so it's not making it very easy for me to check with that one. So what about this one over here? Okay, so this one I can see that there are, in fact, 2 points that I can pick here. Here, this point, and it looks like this point also right over here. So using my definition of proportionality, I want to make sure that the ratio between the two quantities is always the same. And I can do that just by dividing the numbers. So for example, if I take this 10 and this 4, and I do 10 divided by 4, I would get 2.5. And if we take this over here, this would actually be a 5, even though it wasn't written. And this over here, this 2, and we do 5 divided by 2, then that would also give us 2.5. So we can see that the ratio between whatever quantity is represented on the y-axis and whatever quantity is represented on the x-axis, the ratio between those two quantities is always the same, no matter which 2 points we pick. We could pick any other point here, and if we were to divide the y value by the x value, we would get the same answer every time, showing that the ratios are in fact the same. So it does satisfy the definition of proportionality. And again, you don't have to go through this whole explanation every single time. All you have to do as a quick check is make sure that it's a straight line going through the origin, and that's really enough. So that's what I'm going to be doing for the rest of the video. So let's see, which ones here are straight lines going through the origin? So this is a straight line going through the origin, so that's good. This one is a straight line, but it does not go through the origin, so this one would not be proportional. Again, if we were to play that little game that we did before, over here, if I were to do this number, which is 3, where did my pen go? Divided by this number, which is 8. So 3 divided by 8 would be 0.375. Let's pick another point. This point over here, that's 1 on the y-axis and 4 on the x-axis. 1 divided by 4 is equal to 0.25. So you see that this number and this number are not the same, meaning the ratio between x and y here is not the same as the ratio between x and y over here. So again, if those two conditions are not met, meaning straight line going through the origin, if we don't have both of those conditions met, then the graph will end up not being proportional. So this one turned out not to be proportional, and we checked that very easily just by seeing that the line did not go through 0, 0. Okay, so this one is a straight line going through the origin, so this one is proportional. This one is a straight line going through the origin, so this one is proportional. Okay, straight line going through the origin, proportional. Straight line not going through the origin, so not proportional for that one. Straight line going through the origin, straight line going through the origin, good. Straight line going through the origin, good. Straight line not going through the origin, no good. Straight line going through the origin, good. Going through the origin, but not a straight line. This is a curve here, so no good. Straight line going through the origin, straight line going through the origin. Straight line not going through the origin, no. Straight line going through the origin, good. Straight line going through the origin, good. Straight line going through the origin, good. Okay, let's jump ahead. I think all of these are going to be the same, actually. Yeah, so that's it. Just make sure that it is a straight line going through the origin, straight line going through the origin, and then click on it, and you should be able to finish up this skill relatively easily. It's not too tough of an exercise. So if you have any questions, please reach out and have a great day.